Hi, welcome back to my channel Mass Insights. What is meant by a set and how many types of sets are there? What are the operations on the sets? How you will represent a set? These are the very important topics. Before going into deep into the topic, we have to learn the history of the set theory. Set theory was developed by George Cantor, who lived in between 1845 to 1918. So come to know what is meant by a set. Set. Actually, set is a well-defined collection of objects. Set is a well-defined collection of objects. Question arises here, what is meant by well-defined objects? Well-defined objects or ideas means if you take an object, you have to decide whether that object is belonging to that set or not, and also it should have a common property of all the elements in that set. For example, I am taking one thing. See, I am writing A-E-I-O-U. All of you know these are the letters in English alphabet which are called vowels. If I say X, whether this X belongs to this group of letters, everybody says that no, X does not belong to this group of elements. Why? Because all these elements have a common property and we are able to decide any letter which belongs to this group or not. That is called well definition. And also I will take another example which is not well defined. I want to know the students who are very intelligent in the classroom. I will prepare 4 names. What I am thinking, who are the I am thinking that they are intelligent. Suppose I am writing names Ram, okay, Sham, Kamala, Vimala. I thought that these 4 students are very intelligent students in the classroom and I grouped them as a separate one. And I asked one person and I asked one teacher of other subject, sir, Ram is a good student or intelligent student or not? He says that yes, Ram is a good student. And if you ask another teacher, he says that Ram is a not intelligent student. And also if you ask another teacher and if you ask another person, they will say that we don't know about Ram. Ram is an average student. Ram is an intelligent student. So different persons are giving different answers regarding Ram. So I am not able to decide whether Ram belongs to the set of students who are intelligent. These type of sets are not well defined. Why? Because we are not able to decide whether Ram belongs to the group or not. These type of groups are not well defined. So well definition means you have to decide whether that object belongs to that group or not, and also that object should have common property of all the group members. Okay, generally sets are represented with capital letters like A, B, C, X, Y, Z or L, M, N. So sets are represented with capital letters A, B, C, and you may use the letters X, Y, Z or L, M, N, whatever the letters you like, but those should be capital letters. And the elements or the group members are represented with small letters if you are writing English alphabets. Okay, and the elements of a set are enclosed within a flower bracket, and that is also called braces, by separating them with commas. I am writing a set A. that is what I said, you have to enclose all the group elements within brackets called braces, and I am writing the group elements A, E, I, O, U. These are to be separated by commas. And also in the set, you should not repeat an element or number twice. You have to write every element at a time, at once only. This is the way how to define a set, and I think you understand what is meant by a set. Next, you have to write whether an element belongs to a set or not. There is a way how to represent the belongingness of an element in a particular set. Let's write it. See, I am writing a set called A with the elements 1, 2, 3, 4, 5. I am enclosing these elements with flower brackets or called braces. See, these are called elements of the set A. Sets are represented with capital letters. Now, I know that 1 is in the set A. Therefore, I will write 1 belongs to A. This symbol called belongs. You know very well the word belongs means it is connected in that. Okay, and I am taking another element 6. Actually 6 is not in the set A. Therefore 6 does not belongs to A. This symbol says that does not means it is not in the set. So this you have to write belongs symbol, then a cross mark in that is called not belongs to. Not belongs to. So in this way you may write the belongingness of any element of a set by using the symbol belongs or not belongs. Okay, next is very important, how to represent a set. There are different ways to represent a set. The main two ways are roster form or listed form, and second one is set builder form. Okay, if you come to the first one, the name itself says listed form or roster form. If you list all the elements of a particular set and write within the braces by separating with commas, then that representation is called roster form. I am writing a set called B with 5, 10, 15, 20, 25 and so on. This is called a list form. You have to write the elements of the set, all elements of set by separating with commas, then that is called a roster form. It's very simple and very clear also. And coming to the set builder form, this is very important, and some students are feeling difficult in understanding the set builder form. Very simple. In set builder form, instead of writing all the elements of a particular set, we will give a name to all elements, and instead of writing all elements, you will write the common property of all elements. That is the set builder form. For example, I am saying, see, if you take the example of this set itself, I will write the set B in set builder form. What I said, you have to give a common name to all elements. I am giving a common name called X, and you may write colon or slash or vertical line, and we have to write the common property of all elements. If you observe the elements 5, 10, 15, 20 and 25, all are multiples of 5 between 0 and 30. So by giving a common name to all elements, I will write the common property of all elements. X is a multiple of 5 between 0 and 30. You have to enclose this also in braces, and this is the way how to write a set in the set builder form. I will take another example. Let take a set called E, and it has the elements 2, 3, 5, 7. You know, this is called a list form or set builder form. This is called list form or roster form. Now I want to write this set in set builder form. You know, you have to give a common name to each element. So I am giving a common name, let it be Y, and I am writing slash such that you will read it as such that, and you have to write the common property of all these elements. If you observe these elements, these are prime numbers. These are prime numbers less than 10. So write that common property. Y is a number. Y is a prime number less than 10. So this is the way how to write the set in a set builder form. Okay, I think it's very clear to all of you, and we are going to solve different problems in these representations. Types of sets. First and foremost set we are going to be discussed is a null set or empty set or void set. An empty set or null set or void set. The name itself says that empty set. An empty set is a set which do not contain any element in it. That is said to be an empty set or null set or void set. You may find different types of null sets. For example, I am taking a set D. I am writing the set D in set builder form by giving a common name to all the elements as X. X is a prime number. Okay, between 2 and 3. So you have to understand what is a prime number. Then can you find any prime number between 2 and 3? You cannot find any prime number between 2 and 3. That's why you will not write any element and you will write simply braces. That means there is no element in the set. That's why it is called an empty set or void set or a null set. And the separate symbol for representing a null set is pi. This is called pi. Pi is equals to null set. If you find anywhere the symbol pi, you have to assume that that is a null set, means that it does not contain any elements in it. You may take different types of sets which are empty. Okay, and next type of set is finite set. Very simple. The name itself says that finite means if there are finite number of elements in a particular set, that set to be said to be a finite set. There is a limitation for the number of elements, then that is called finite. Suppose I am writing the set A and with elements 3, 4, 5. See, I am not writing and so on. If you are not writing and so on, means you are stopping there, and these are the only elements in the set. Then that type of sets are said to be finite sets. And coming to next type of sets, infinite sets. Very opposite to the finite sets. See, in finite sets you will find limited number of elements, but in finite sets you will have infinite, means there is no end for number of elements in it. You have different types of example. All sets of numbers are infinite. Suppose natural numbers, set of natural numbers starting with 1, you cannot find the ending number in natural numbers. You will write n is equals to 1 comma 2 comma 3 comma 4 and so on, and so on means there is no end to the list of these elements. Therefore you will call this set as infinite set. And also whole numbers, integers, rational numbers, irrational numbers, real numbers, all these are examples for infinite sets. Okay, next, coming to next very important topic, very important title called subset. Sub, the name itself says sub inspector, means who is under inspector. Inspector is superior and this sub inspector is under to him. So we will understand that subset of a set is the set which contains all elements of it in another set. Suppose I am taking two sets A comma B and I am writing the set A with elements 1, 2, 3 and I am writing another set B with 1, 2, 3, 4. If you observe, all the elements of set A are in set B, then you will say that the set A is subset to B. Okay, I will write this as by using symbol subset. If you find this symbol in somewhere, you have to understand that the set A is subset to B. That means all the elements of A are in B. That's why we are calling the set A as subset to set to B. Similarly, this set B is having one element more than this. That's why it is called superset. Very simple, superset. If you come to example, if you take this example again, the elements of A are in B. That's why A is called subset of B, and B is having one more element than A. That's why B is calling as superset. And the symbolically, if you want to represent, A may be written as subset to B and B is written as superset to A. You have to use reverse symbol as used in representation of subset. So A is subset to B and B is superset to A. And sometimes these two sets will have equal elements in them. Suppose I am taking a set C. Set C is having the elements X, Y, Z, and set D is having Y, Z, X. These two are having same number of elements, and you know that there is no preference for the order. See, in the set C I am writing X first, but in the set D I am writing X in the last position. Wherever it will be, that doesn't matter. Whether the element is in it or not is very important. And if you see, all the elements of C are in D, therefore you will say that the set C is subset to D, and D is also subset to C. Therefore you may write C is subset or equals to D, and also D is subset or equals to C. In these cases you will find that the set C is equals to D. Very simple. If first set is subset or equals to second set and second set is subset or equals to first set, then those two sets must be equal. This is the concept of subset and superset. Next definition in the types of sets is equivalent sets. I think it is number 6. Equivalent sets. If you take two sets A and B, then they are said to be equivalent sets if they have equal number of elements in them. Whatever the elements they are containing, that is not matter. Whether they are containing equal number of elements or not, that is the matter. Suppose I am taking the set A with elements 1, 2, 3 and another set B with elements A, B, C. If you observe these two sets, you will find that the set A is containing 3 elements in it, and also the set B is containing 3 elements in it, and you will say that these two sets are containing equal number of elements in them, therefore they are said to be equivalent sets. You will find lot of equivalent sets in the set theory. And next, coming to very important definition, equal sets. Equal sets. If you say that two sets are equal, they should have equal number of elements along with same elements. Suppose I am taking a set C 1, 2, 3 and set D. This should also contain the same elements. Whatever the order may be, you know that order may not be a preferential concept in this set theory. If you observe, C is containing 1, 2, 3 and D is containing 2, 1, 3. If you observe, 1 is in the set D and also 2 is in the set D, 3 is also in the set D. Therefore, these two sets C and D are having equal number of elements in them along with same elements. Therefore, you will write C is equals to D or C is equals to D. And in this case, if two sets are equivalent, then you will write A is equivalent to B. That means they are having equal number of elements only, but these two sets are having equal number of elements along with same elements. So these are the some definitions, and you have more definitions on this set theory. So whatever we discussed so far, we will have problems in the next video, and we are going to solve those problems in the next video. If you like my video, please subscribe, share, and this will give me an encouragement to do more videos on important topics. Thank you.